All right, this is the video for section 5.3, part 1. So section 5.3 is entitled Rational Exponents and Roots. And what we're going to take a look at here is the relationship between rational exponents. And remember, rational exponents are just exponents that can be written as fractions. Remember that word ratio is part of the word rational. So we're going to look at the connection between fractional or rational exponents and using roots or using radicals. We're pretty familiar with using a square root, but that's not the only type of root out there. So let's take a look here at some introductory problems, and some of these we'll do in our head. So it says to evaluate each expression, which just means to find the value of each expression. The first one just says the square root of 49. And so we think to ourselves, what number times itself equals 49? And that number is 7. 49 is a perfect square, so we can do that problem in our head. You might also argue that negative 7 squared is also 49, which is true. But when we're given a square root to find, and right here we're just given the square root of 49, the answer that we write is going to be the positive version. It's called the principal square root. So the square root of 49 is 7. Let's explore what happens when we raise 49 to the 1/2 power. And let's use our calculator to do that. Oh, my calculator here hasn't been opened, so we're going to have to wait for it to validate the license. So you can talk amongst yourselves as we wait for the license to be validated. I hope you had a good morning. Hope advisory was good. First block was good. Second block. Okay, we're finally here. So again, what I want us to explore is taking 49 and raising it to the power of 1/2. I'm going to use some parentheses here. 49 raised to the 1/2 power. Whoops, let me start that over again. 49 raised to the, in parentheses, 1/2. And your calculator might look different, once again, depending on the operating system of your calculator. But if we do 49 to the 1/2 power, you also could do 49 to the 0.5, the decimal equivalent of 1/2. You'll see that we also get 7. So the square root of 49 is 7. And 49 to the 1/2 power is also 7. So there's a connection between raising to the 1/2 power and taking the square roots. And the same goes here even if we have a number that's not so pretty and a number that's not a perfect square. The square root of 12 we could do on our calculator. We can do second squared to get the square roots. And we see that the square root of 12 is about 3.46. I'm going to change that equal to an approximately equal to. About 3.46. And our hypothesis would be that 12 to the 1/2 power would also give us about 3.46, because that's what happened with the 49, so it should happen with the 12s as well. Let's just verify that on the calculator. If we take 12 and raise it to the 1/2 power, and this time I think I'll raise it, instead of writing 1/2, maybe I'll use 0.5, the decimal version of 1/2. 12 raised to the 0.5 power is also equal to 3.46, about. So the square root of 12 is about 3.46, and 12 raised to the 1/2 power is about 3.46. So what we're observing here again is that the square root, taking the square root of a number, is the same thing as raising it to the 1/2 power. It's just two different ways of writing the same idea. Again, let's make sure we have this written down. Fractional exponents are called rational exponents. So if a problem ever says to solve using rational exponents or rewrite in rational form, you're being asked to introduce a fraction into the picture. So the observation we made is that we can rewrite the square root of x as x raised to the 1/2 power. And then I want to write that one other slightly different way. Go ahead and write the square root of x. But what you have to know is that when we write this symbol here, we could call it a square root symbol, but better yet, we'd call it the radical or maybe even the root symbol. And something that we never write when we're taking a square root, but we really could, is a little 2 right there in front of the symbol. And that 2 in front is saying that we're going to take the square root. So if you didn't know this already, we could take other types of roots. We could take cube roots or fourth roots. Before we explore that anymore, maybe off to the side here, how about you write this down? The square root of 16. Right, the square root of 16 is 4. We don't normally write it, but we could write a little 2 up here in front of the radical to show that we're taking the square root. Let's look at something different. Let's say I had a little 3 in front of that radical symbol, and underneath I had 27. This notation here isn't asking you to find the square root of 27. It's asking you to find the cube root of 27. So rather than think to yourself what number times itself is 27, we'd think to ourselves what number cubed is 27. And hopefully 27 is a familiar enough number that we know the answer to this would be 3. The cube root of 27 is 3 because 3 to the third equals 27. So when we write the square root symbol, and again, we really shouldn't call it the square root symbol anymore. We should just call it the radical or the root symbol. And if we don't write a 2 up here, and you don't have to write the 2, if there's no number written up here, it means square root. But other numbers could be written up here to mean cube root or fourth root or fifth root, all the way up as high as you'd like. Okay. So in general, this is a specific example up here with a square root and a 1/2 power. Here's the rule in general. In general, if you had something that looks like this, a to the m over n. So that's a base with a rational exponent. We can always rewrite that using a root instead of using an exponent. You just have to remember where these different items go. That denominator on the rational exponent, the n, that's like the type of root we're taking. So that number goes in front of the radical. Underneath the radical, we're going to put our base. And the m, the numerator on that original exponent, is going to still be an exponent on the a. So a to the m over n, that's rational exponent notation. We can rewrite in root notation. And we would say this as the nth root of a raised to the m. And then there's one alternate way of writing things. I'm going to put this in parentheses. We could rewrite this as the nth root of a, and then all of that raised to the m. So that's an alternate way of writing things. And that way of writing things won't come up as often, but it's still something I want you to be aware of. So a to the m over n is the same thing as the nth root of the nth root of a to the m, or we could write it as the nth root of a, all raised to the m. Let's take a look at a couple examples. So the instructions say to rewrite each exponential expression using roots instead of exponents. So that's what we're going to do. On part A, we have x to the 1/2 power. We're going to rewrite this using a root. All you have to do is really memorize where these pieces go. The denominator of the fraction is the type of root we're taking. The base goes right under the radical. And then the numerator of the fraction is the exponent on that base. Now, we would never leave our answer for this one like this. We would never actually put the 2 here, because remember, if there's no number up here, it automatically means the square root, so we don't actually need that 2 there. And additionally, x to the first, we usually don't write that x. So it's simplest to just write the square root of x for that first one. I'm going to skip down to part C, so take a look at that one. For part C, we have a to the 3/2 power. We're going to switch to root notation. The denominator of the fraction is the type of root you're taking. And then underneath the radical, we keep that base of a, and we raise that base of a to the numerator from the fraction. Again, here we have the square root of a to the third. So we don't actually need to keep that 2 to show that it's a square root. So we'll rewrite our final answer as the square root of a to the third. Now, if this number over here in front of the radical was anything other than 2, then we would want to leave the number there. So if this was a 3 or a 4, we would keep it in our final answer. Go ahead and try B and D, and then the substitute will just check in with you about those correct answers, and then we'll move on to something else.